Okay, this is video 2 from your lesson on scientific notation. So the rule for converting from scientific to standard notation, which is what we completed on the last video, the exponent determines how many places to move the decimal point and which direction to move it in. A negative exponent tells us to move the decimal point to the left when we're converting to standard notation, and a positive exponent tells us to move the decimal point to the right. So that was converting from scientific to standard notation. Now we're going to be converting from standard notation to scientific notation. So taking a number in standard form and changing it to a number between 1 and 10 times some power of 10. So if I have 187 million and I want to change that to scientific notation, remember the rule is place your decimal point behind the first non-zero digit starting from the left. So that makes it 1.87. Write down all your non-zero digits. Now if I have a 0 and then another non-zero number, of course I do have to include that one. And then figure out how many places you moved your decimal point to get it there. In other words, to get your decimal point there. Where is my decimal point when there isn't one showing? It's all the way at the end, right there. So I had to move it 1, 2, 3, 4, 5, 6, 7, 8 places. I had to move my decimal point 8 places to get it from the end to behind the first non-zero digit. So that's why it's multiplied by 10 to the 8th power, and therefore I got 1.87 times 10 to the 8th power. I started out with a number greater than 1, so my exponent is positive. Okay? Before, when we had a positive exponent, we were changing it to standard notation. We knew if our exponent was positive, our number answer was going to be, in standard notation, greater than 1. Now I have a number that's less than 1 when I start, and that tells me that my scientific notation power on 10 is going to be a negative number because my number is starting out as a number less than 1. So remember the rule is we have to move our decimal point so that it is behind the first non-zero number. That puts it behind the 7. And then I have to figure out how many places I moved it. It was in front of the 0. I moved it 1, 2, 3, 4, 5 places. So it becomes 7.465, the remaining non-zero digits, times 10 to the negative 5th because I started out with a number less than 1. Okay, so let's try some. I have 354,000. My decimal point is understood to be at the end right there, and I need it to be behind the first non-zero number right there. So I'm going to move it 1, 2, 3, 4, 5 places. That means I'm going to have 3.54 times 10, and to determine the power, how many places did I move my decimal point? Again, I moved it 1, 2, 3, 4, 5 places. And then to decide whether the exponent is going to be positive or negative, did your number start out bigger than 1 or less than 1? It was a bigger number than 1. It was 354,000. So my exponent is positive. If I move over to 0.000239, here's my decimal point now. I need it to be behind the first non-zero number. So I'm going to end up with 2.39 times 10, and what power am I raising that to? The number of places I moved my decimal point, which is 1, 2, 3, 4. My number started out a number less than 1, so my exponent is negative. Okay, 0.046. Put my decimal point behind my first non-zero number, so I'm going to have 4.6 times 10, and the number of places that I moved that was 2, so my power is 2. My number started out a number smaller than 1, so my exponent is negative. Okay. Now the next one says write in scientific notation. I have 258 times 10 to the 5th, and that might already appear to be in scientific notation because I'm multiplying by 10 raised to some integer power. The problem is 258 is not a number between 1 and 10, and it needs to be a number between 1 and 10. So that's the first thing I have to do. Take the 258 and turn that into scientific notation. My decimal point is at the end of the 8. I need to put it behind the 2, so I have 2.58 times 10 to the 2nd power because I moved it 2 places. It was a number bigger than 1, so my exponent is positive, and now I multiply by 10 to the 5th power. So I have 2.58 times 10 squared times 10 to the 5th. Now you can see why this lesson is placed where it is. We just figured out in today's class what to do with 10 squared times 10 to the 5th. If I have like bases raised to powers, what do I do with those powers? I add them. So it's 2.58 times 10 to the 7th power. And that's my final answer. Okay, let's move down to 33 times 10 to the negative 6. Again, it almost looks like I'm in scientific notation. The reason that it isn't is because 33 is not a number between 1 and 10. It's greater than 10. So the first thing I'm going to do is move my decimal point from where it is behind the second 3 to between the two 3's. So that gives me 3.3 times 10 to the first power, because I moved it one place, times 10 to the negative 6th power. So now that gives me 3.3 times 10 to the negative 5th power. How did I get negative 5? I added 1 to negative 6. 1 plus negative 6 gives me negative 5. Okay, so again, remember, your answer is not in scientific notation unless it is a number between 1 and 10 multiplied by 10 to some power. So just because it's multiplied by 10 to some integer power does not necessarily mean the number is already in scientific notation. So I want you to try these last two. I'll go over them in class on Monday, and be sure to watch the next video on this lesson, because that gives us a few problems that are slightly more complicated than this one.